Hello, I'm Param Singh. Hope you guys are doing well. In the last video, we solved this first problem to compute the length of the list using the function design recipe and the function design template for lists, which is a recursive data. And then we left off with a second problem to try on our own and mentioned that the solution is going to be quite similar to the first problem with small changes in the final implementation. So I hope you had some time to reflect on this problem and tried a solution on your own, and maybe you were able to solve the full design on your own, and that's great. But in this video, we are going to design this solution and review the solution together. Okay, so the problem is to sum the numbers of a list. Design a function to sum a list of numbers. Let's start with our function signature, and we'll call this as list sum, and it should take a number and give us a number. So it's taking a list of numbers and producing the sum of the numbers. So the return type is going to be number. Then we write our purpose statement. Compute the sum of a given list of numbers. So this is our purpose. Then we go down and write the stub. That means we start with function definition of list sum and give it a list that we want. So the simplest list that we can give to this function will be a list of 0 elements, and the implementation, since the output return type is a number, let's just put in a 0 there. Okay, now let's move on to our test file and write some of our tests. So I'm just gonna say here that tests for list sum, and our tests are gonna be here. I'm gonna take a little shortcut, and instead of writing individual functions, I'm gonna wrap multiple assert statements within this list sum test here. So what that means is I'm gonna say my list sum for the empty list should give me 0, right? So if the list is empty, there are no elements in there, that we are going to produce a 0 sum there. Then we are going to say my list sum, and let's put a list of 1 element, and I'm going to say 42 is going to be equal to 42. Let's write a list of 2 elements, and this time we'll move to floating point numbers. So 1.3, 2.4 should give me 3.7. So we have 3 cases here, and this is what I want to also emphasize, that when designing tests for lists, you want to have at least 3 cases. Number 1, you must have a base case to test. And then you must have a test with one element, and most importantly, another test with two elements, because a one element list may pass your test without having a successful or correct implementation of the recursive case. So that's why it is important to have a test with two elements. So let's go back to our implementation file, and I'm going to run mix test for once, and it says function clause error. So that's our new function that we just wrote the tests for, mylist.listSum. And we are not going to worry too much about the error at the moment because we have not written our implementation yet. So the next step will be to write both clauses, the non-self-reference or the base case clause, and then a self-reference clause. So if you remember from our video on how to design the body of a function that consumes a list, this is our base case clause, if you will. So we have a list sum, it takes an empty list, and eventually we are going to write an implementation. But for now, we'll just move on to the second clause, which is the recursive clause. So in the recursive clause, we will pattern match the list. So we have a head and tail, and then we have two pieces of information to work with. So we have head, and do you recall what the second piece is? So it's not tail, it is list sum applied to the tail. So these are the two pieces that we have to work with. Now we will think about the implementation. So first we'll implement the base case. Working on the base case is really trivial. That is defined in our tests here, that the sum of the empty list should be 0. So we're going to take that information and just say sum of empty list 0, and that's our base case. Save case now. Let's think about how do we solve this problem. By looking at these two pieces, imagine that you already have this as a result, and how can we use this result in our calculation? So we already have a sum of the tail of the list, and then we have a head of the list. So bulk of the work is already done for us by the second piece, which is the sum of the tail of the list. And it is not a huge jump to then say that the sum of the list is the head plus the sum of the tail of the list. So that's it. So this is our implementation of the list sum. Just to make sure that this is working, we'll go back and run our mix test, and our tests pass. So this is very interesting and very powerful way to solve these types of problems, where you have an arbitrary size data, and we have a function design recipe that helps us do quite a bit of work in small pieces. But on the top of it, we also have a template of the body that helps us to write the final implementation in a stepwise and systematic fashion.